Hello everyone, Gaza Mutkarsh and I welcome you all to this session on Numpy for numerical calculations. So guys, let's have a look at the agenda for this session. Till the previous modules, we have discussed variables, data types, operators, functions, modular scripts, along with list, tuple, set, dictionary, and list comprehension. Now, in this module, along with this session, we'll be discussing NumPy arrays and list. We'll be discussing different methods to create NumPy array, and we shall also be focusing upon NumPy random numbers, how to create random numbers using NumPy. So I'm switching to the Jupyter screen. So guys, let's understand what NumPy is. So guys, NumPy stands for numerical Python. It serves as a foundational library / package for numerical computing in Python. So let's say it introduces support for large multi-dimensional arrays and matrices along with extensive collection of high-level, let's say mathematical functions designed to operate on these arrays. So essentially हम यहाँ पे arrays बना सकते हैं and we do have n number of different functions to work on these arrays, to manipulate the array, let's say to combine them, to perform mathematical operations on matrices, arrays, and even higher dimensional data, provided the data is numerical data, right? So let's understand कि NumPy में the core data type that we have. Essentially Python में as of now we have discussed n number of data types, right? What all data types we have discussed? We have discussed integer, float, boolean, string, none, and then we have also discussed list, tuple, set, and dictionary. Now, besides these data types, when we introduce couple of packages and let's say libraries, we do tend to get other data types as well. Now, one such data type that is introduced along with NumPy is NumPy arrays. So what are arrays? Now, a NumPy array is a powerful n-dimensional array object provided by the NumPy library. So essentially, it is a sequence of data points, all right? Let's say, and all these data points are homogeneous in nature. Means all the elements in a NumPy array are homogeneous. We cannot have different elements, different data types in a single NumPy array. So it is used for performing, why do we use the NumPy array? So it is used for performing fast and efficient operations on large data sets, especially in scientific computing, data analysis, machine learning, artificial intelligence, and even generative AI. NumPy's core functionality revolves around the ND array. Now, when I talk about ND array stands for n-dimensional array. We can have one-dimensional data, we can have two-dimensional data, three-dimensional data, and even n-dimensional data. So n-dimensional data is nothing but a homogeneous n-dimensional array object that enables representation and manipulation of numerical data in structured and optimized manner. Now, these operations we can, let's say, couple of these operations that we will be performing in NumPy can also be implemented using list. So why there is a switch from list to the NumPy array, we'll come to that answer as well. Now, it's not just limited to array and let's say matrix operations. So beyond its array capabilities, NumPy provides a rich set of functions for tasks such as linear algebra, scientific computing, Fourier transformations, random number generation, and much more. In fact, the machine learning algorithms, when you see the background code, the code is essentially written in NumPy array format, utilizing the NumPy array capabilities. Now, it's imperative to understand the difference between the list and the NumPy array because their representation is very much similar. So let's understand the difference when we talk about data type, right? So array, the NumPy array that we're talking about is exclusively homogeneous. All the elements must be of the same data type. Whereas when we talk about list, list can be homogeneous as well as heterogeneous. Means it does allow heterogeneous data type. So it can contain mixed types. Now, when we talk about performance, so arrays are faster, optimized for numerical operations. While when we talk about list, so lists are slower when we come to the numerical calculations. Performance wise, again, array is faster, optimized for numerical calculations, and list is slower for numerical computations. Talking about memory usage, so array consumes less memory, and let's say list, when utilized to the full capacity, they consume way more memory. NumPy arrays do provide broadcasting facilities. Broadcasting simply means, let's say, automatic expansion of shapes of n-dimensional data, whereas to implement the same, let's say when we talk about list, we'll have to use multi-dimensional, let's say nested listing. All right, so directly it's not supported. Maybe using nested listing it can be implemented, or maybe utilizing some custom algorithms it can be implemented. Now, when we talk about multi-dimensional support, so this is where arrays are efficient as far as multi-dimensional arrays are concerned. All right, and whereas when we talk about list, so they need nesting for multi-dimensional data. List do need nesting for multi-dimensional data. Now let's understand how do we create arrays. Now NumPy provides different types of functions for creating arrays. All right, so talking about these functions, the first one is np.array, then we have np.arange, then we have, let's say, np.ones, and maybe we have np.zeros. So all these functions allow creating custom arrays, right? So how do we import NumPy? We can import NumPy like this. Import NumPy as np. Over here I'm importing NumPy as np, where np is the alias name. So this is how we tend to import a library. Now usually we go with the alias name np. We don't change it often. Now as discussed, np array. So this is the first function that we'll be using to create a NumPy array, right? This is the first function that we are going to use. So np.array, the data type of NumPy array is nd array. Now we can create NumPy array using a list or a tuple. So an array is usually fixed size container of items of same data type and size. Now homogeneity is the most important property of a NumPy array and it cannot be violated. So the number of dimensions and items in the array is defined by its shape. So let's understand. Currently I'm having a list. All right. We can check what is the data type of w1. Type of w1 is a list. All right, guys, over here I can see that it is a list. How to convert it to NumPy array? I can use the array function and I'll be writing w1 and I'm storing it in w2. All right, and then I can display w1. So as you can see, the structure, the feel and the lookalike of a NumPy array is very much similar to that of list. Now what are the key differences? First, let's talk about similarities. Both list and NumPy array are represented in square brackets. All right. The striking difference in terms of appearance is that list elements are comma separated, whereas NumPy elements are space separated. And how do we check the type of w1? So it is a NumPy array. Now every NumPy array has these properties. What are these properties? The first property is dtype. Dtype returns the data type of the NumPy array. Size returns the number of elements of the array. Shape returns the shape in tuple of the nd array. We'll talk more about shape. Then we have ndim. Ndim returns the number of dimension. So this is where we can, let's say, scale up the dimension. That is ndim. We can have 0-dimensional array, 1-dimensional, 2-dimensional, 3-dimensional, and n-dimensional array. Now, based on these properties, there are two more essential things that we have to be mindful about. The product of shape, because the shape would be in form of tuple, the product of numbers in the shape when multiplied would return the size, and the count of shape elements would be the number of dimensions. So let's consider an example. First, I'm considering an example of 1D array. All right, this is going to be 1D array. Let's see. So over here I'm writing n1. This is np.array. I'm considering just maybe 5 elements, maybe 20, 24, 26, 15 and 10, and then I'm printing n1. Over here I'm printing n1, and then over here I can print type of n1. What is the data type? The data type is nd array. Now besides the nd array, what else let's say do I need to display? I need to check what is the shape. What is the d type? The data type, all the elements are of integer. Please check the elements are integer. Next I can check the size, how many total elements are present. So in a total of, we have 5 elements. This is integer, this is 5. Then I can check the shape. First let's check the dimension. So how many dimensions do we expect? There is only 1 dimension. How do we decide the dimension? Just observe the number of opening brackets or the number of closing brackets. How many do we have? We have only 1. Next, over here I can figure out d type, size, ndim, and then we have shape. Now shape would be in form of tuple, because this is 1D. Shape would be 5 comma 5 comma, indicating only 5 elements, and this is 1 dimensional. All right, so this is how, let's say, the 4 properties of NumPy array are defined. Now we'll get to understand shape better when we consider 2D array. So I hope this example is clear. That all the elements are of integer data type, the size is 5, ndim is 1, and the shape is 5 comma. Now let's consider a 2D array. So guys, if I were to consider a 2D array, over here I'm writing n2. N2 would be np.array. Then I'm passing couple of elements, maybe let's say 5, 8, 12, 14. And then I'm passing maybe 20, 24, 27, and 32. Now if I print n2, this is numpy array. Now if I print type of n2, this would be nd array. Let's observe the properties. N2 dot let's say the first property is d type, all the elements are integer. Then the second property would be n2 dot size. What is how many total elements are present? This is d type is integer, the size would be 8. Total of 8 elements are present. Now what would be the dimension? How many opening and closing brackets do we see? In the opening we see 2 brackets, in the closing we see 2 brackets. So in a total of we have over 8 elements, right? The dimension is 2. The number of the size, total number of elements that we have over here is 8. The dimension that we count is 2. What about shape? Now shape, if you observe carefully, this is a 2-dimensional data, right? Means tuple would contain 2 elements, comma separated 2 elements. First would be the number of rows. So clearly we can see row number 0, row number 1, and we have 4 columns. First column, second column, third column, fourth column. So this would be 2 into 4. 2 indicating number of rows, and let's say 4 indicating number of columns. So for 2-dimensional, the data is in tabular format. So we can consider this 2 rows and 4 columns. We can also have 3D data. Let's see 3D array. How do we interpret or visualize 3D array? So I'm currently copying the same. Instead of n2, I'll be using n3. Now this is first, let's say the first of the 2 dimensions, and I'll be incorporating another 2D array. Over here the numbers would be maybe 51, 52, 53, 54, and then maybe 80, 90, 100, 120. Now if you observe n3, let's comment these 3 lines. If you observe n3, this is a 3-dimensional data. Why 3-dimensional? Because we have, let's say we have stacked let's say 2 dimensions twice. So if 1 dimension is stacked twice, it becomes 2D. If 2 dimension is stacked more than once, it becomes 3D. Alright, so the data type is integer. How many elements are total present? 8 in the first 2D array, 8 in the second 2D array. So the total number of elements would be 16. Size is 16. Number of dimensions, if you observe the number of brackets in the beginning or at the end, it is 3, indicating it is 3D array. What about the shape? So if the shape over here is C, previously we have observed this is 2 rows, 4 columns, right? Now how many elements, how many 2 rows, 4 columns? The third dimension is the number of 2D arrays that we have of the shape 2, 4. So the third dimension is 2. Why 2? Because this is the first 2D array, this is the second 2D array, right? So over here I'll call it the third dimension. The third dimension is 2, and so this is the shape. This is the shape that we have observed, right? So guys, if we observe next, we have a total of 16 elements. In this example, we have 16 elements. The endim is 3, and the shape observed over here is 2 to 4. Now let's consider another example. Now this is 0D array. Now 0D array has literally no data, or just let's say n0, np.array. There would just be one element without any bracket. Suppose I'm passing 7, and if I print n0, if I print, let's say, type of n0, and then after type I can simply copy this part, right? I'll simply copy this part. Now this is n0, 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 n0. So the data type is integer, size is 1, endim would be 0, and the shape would be an empty tuple. See, integer 1, endim is 0, and the shape is an empty tuple. Alright, so guys, I hope this is clear to everyone. Next, let's understand. So far we have discussed 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional array. Now we have couple of other functions to, let's say, incorporate the array creation. Next is a range function. We have discussed the range function previously, right, in the for loops concept. So what does a range function do? It is very much similar to that of the range function. The benefit with a range is that it also supports, let's say, array creation on float data type, which was not initially supported with the range function. So over here, if I'm writing for I in range 5 comma 25 comma 2, so we know how this works. Over here the start is 5, the end is 25, and what is the step size? The step size is plus 2. This is the let's say this is how, let's say, we can create for loop. This is how we can iterate on the range, in the specified range. Now using NumPy we can utilize the same concept. Let's have a look at this example. np.range 3 comma 10. What does this indicate? It is starting at 3, it is ending at 10, and what is the step size? The step size used over here is plus 1. All right, over here the step size is plus 1. So if I just display this, see, it is going all the way up to 3 to 9 because this is an ascending order, so it works till end minus 1. Now in the second example, 4 comma 20 comma 3, what is the start, end, and step? Start is 4, end is 20. This is 4, 20, and the step size is 3. So it would be 4, 7, 10, 13, 16, 19, and so on, right? So this is how we can observe the values. This is how we can observe the values, right? So guys, I hope this example is clear to everyone. Next, besides these functions, now it also works on float. I'll give you another example. X3 would be np.arange, and in the a range over here I do wish to pass maybe, let's say, 0.5 to maybe 2.3, 2.4 with a step size of 0.2. All right, and then I wish to print x3. So when I print x3, so, and observe the data type as well, please see, so 0.5, then 0.2 and added, so this becomes 0.7, 0.9, 1.1, 1.3, it goes all the way up to 2.3, right? So clearly we have observed the start, end, and step over here. What is my start? The start over here is 0.5. What is the end? The end over here is 2.4. And what is the step size? The step size is 0.2. All right, so this is the data that we have. Next we have np.ones and np.zeros. So let's understand np.ones. So it is used to create an array of custom shape with all values as 0. Okay, this is ones, right? So this would be 1 and this would be 0. So this is with all values 0. So let's see this in action. So I'm writing let's say maybe t1. T1 is np.ones, and the shape that I wish to pass is maybe 3 comma 4, indicating the number of rows is 3, the number of columns is 4. So now if I print T1 in the shape 3 comma 4, I'll be obtaining all ones. Why am I getting decimal? Because the data type by default data type is d type used by default is float. So if I wish to convert this, what can be done? I can write d type as integer. Correct. Now if I use t2, so np.ones, then over here I'll be writing 5 comma 3, and the d type, okay, I'll keep the d type as float. So over here all the elements are of ones, I'll change it to zeros. All right, so guys, clearly we can observe that all the elements are now zeros. So what is the number of rows that we have in this example? The number of rows is 5. And what is the number of columns? The number of columns that we are utilizing over here is 3. All right, so in 5 rows and 3 columns we have obtained all the elements as 0. Next we have another function to create an array, which is, let's say, np.linspace. Linspace, let's say, generates linearly spaced elements. It generates linearly spaced elements, all right, in a specified range. Then maybe we can, okay, let's say this is the first point. So let's understand the first point first. For instance, I want to create an array R1 np.linspace. Between 2 and 10 I want 5 elements. So what are the 3 parameters over here? Start, stop, and number. It is not the range, it is number. All right, so start is 2 and the stop is 10, and what is the number? The number used is 5. So now if I print R1, see, it is generating 5 linearly spaced let's say numbers between the specified range 2 and 10. Linearly spaced indicating the difference between any two consecutive numbers would be constant. Difference between 2 and 4 is 2, difference between 4 and 6 is 2, between 6 and 8 is 2, and between 8 and 10 is again 2. All right, next I'll give you another example, np.linspace. Now what if the space between the two start and stop numbers, they are not let's say we are not able to fetch it as integer. So how do we proceed then? So it would be converted to float. What I'm saying is, suppose between 2 to 10, if I want 7 integers. Now, I won't be able to find 7 linearly spaced elements in the range 2 to 10 in the integer domain, right? So then it will shift to float domain automatically. So start is 2, and what is my stop? Stop over here would be 10, and what is the numbers? The number over here is 7, right? So now if I print R2, see 2 and then 3.33. So what is the difference between 2 and 3.33? 1.33. Then between 3.33 and 4.66, again 1.33. Between 4.66 and 6, again that would be the 1.33. Between 6 and 7.33, 1.33. So the difference is constant. If we wish to see the difference, even that is possible. Let's see how. So np dot len space, maybe I'm passing 3,20, and I want maybe, let's say, 8 numbers. So let's see what do we get. This is what I'm getting. Okay, let's say 7 numbers, 4 numbers. Okay, let's go for 9 numbers. This is what I have, right? Now there's another parameter that will display the difference. So if I pass red step, is equal to true, so it will display the difference. The difference is 2.125. This is the difference between any two pairs of consecutive numbers. Now again, the output generated is of the data type numpy array. How do we check? Type of R1, and even over here I can write type of R2. So this is numpy array, and if I check type of R3 as well, the output obtained is a, okay, currently it is a tuple, but if I were to check R30, this is the numpy array, because there are two outputs contained within a single variable. That is why it is generating a tuple, but individually this is a, this array part, this is numpy array, right? This is essentially the numpy array. Now numpy also allows to generate random numbers, and to generate random numbers we have to use np.random dot, and then np is the library, random is the module, and then we have to pass the function utilized, any function that we wish to use. So the first function that we are going to discuss is np.random.random. So np.random.random returns random floats in the half open interval. What is the interval used? The interval used is 0.0 to 1.0. So over here I'm passing np.random.random 3, 4. 3, 4 indicates rows and the columns. So how many rows do we have? Over here I'm passing 3 rows. And how many columns do I have over here? Over here I'm having 4 columns. So now when I'm printing G1, observe this. Now when I'm printing G1, the output is displayed in 3 rows, 4 columns. Can I change this? Yes, I want to display it in 5, 2. So it would be 5 rows, 2 columns. Now what are these numbers? These are randomly generated numbers between a specified range. So why do we use this random library? Let's say to generate synthetic data or to simulate certain problem statements where synthetic random data is required. So that is the most commonly utilized use case in the industries. Next we have np.random.random integer. So because suppose I want to generate sales, I want to generate salaries, I want to generate marks. So I don't want floats, right? I want maybe integers. So that is when random.random integer comes into picture. So over here I need to pass low, high and size. So it returns random integers from low inclusive to high exclusive. How do we pass this? Over here I'm passing ages. Okay, instead of age, let's consider a different thing. I want to generate sales maybe for let's say 100 days, right? 100 days, and np.random.random integer. I want my sales to vary between maybe, let's say, 2000 to 8000. How many integers? I want 100 random numbers. So please observe what is the sales dot shape. How many numbers I'm getting? I'm getting 100 numbers. Then if you want to see the numbers, see these are the 100 random numbers generated between 2000 to 8000. If I want to know what is the minimum and the maximum, so I can use let's say np.minimum sales and np.maximum sales. Now these numbers would vary every time I rerun this, because these numbers are randomly generated, so they would vary. As we can see clearly, these numbers are changing, right? Alright, so guys, this is how we can generate random integers as well. Besides random integer, I'll give you another example. Let's say over here I'm considering marks. So I'm expecting the student marks to, let's say, lie in the range maybe somewhere between 65 and 60 to 95. How many marks do I want to generate? I want to generate 50 marks. So 50 over here is not the, let's say, step size. Let's say this is low, high, and the number. The low is 60. What is high? The high is 95. And what is the step size? The step size is 50. So guys, this is the marks obtained, right? These are the marks obtained. Every time I rerun this, this would change. So guys, I hope you have understood how to utilize NumPy random numbers generation. So we have seen, let's say we have understood the concept of NumPy arrays. We have also discussed the difference between list and the NumPy arrays. And we have discussed a couple of functions utilizing which we can create NumPy arrays, followed by NumPy random number generation, right? So guys, that brings us to the end of this session. Let's switch back to the PPT. So guys, in this session, we have understood the difference between arrays and lists. We have understood the concept of NumPy arrays, how to create arrays in the first place, and why are we so much inclined towards utilizing arrays in the data science, machine learning, and AI domain. We have discussed different array creation functions, and we have also discussed how to utilize arrays effectively, right? So guys, that brings us to the end of this session. Now, so far in this session, we have discussed, we have understood the difference between arrays and lists. We have understood how to import the NumPy library, what are the different functions utilizing which we can create arrays. We have seen how, let's say, different functions can be utilized to, let's say, manipulate the arrays as well, right? And we have understood how to utilize arrays effectively. So guys, in the next session, we shall be proceeding with indexing and slicing on the NumPy arrays. Thank you.